All right, here we go. Study guide for the Unit 2 exam. Unit 2 exam is worth 3 times as much as the quizzes. So here we go. All right, making quadrilaterals. Draw a triangle. Okay. This is on page 172, by the way. Let me just go turn the lights on. All right, got all my tools ready to roll. Geometry, you usually need a protractor, compass. I love these perfectly sharpened pencils on compasses. That's always nice. I like to use color in my drawings a lot. So, sharpen those pencils, get them ready to roll. Use a lot of color, it helps a ton. At least I was always one of those visual learners. All right, so draw a triangle, easy, right? Step 2 is find the midpoint of the longest side. Step 3 is to rotate it 180 using the midpoint. And then label corresponding parts, mark what must be congruent. Last step, make a conjecture. What is a conjecture? That's an educated guess. All right, here we go. Easy peasy. These are our new pencil sharpeners. Got new seats coming up, Unit 3. I let you pick your seat partner if you're willing to sit up front. And if you're not willing to sit up front, that's okay too. But that just means I'm gonna pick your seat partner. So, all right, here we go. Draw a triangle. Okay, first step. How do you draw a triangle? Oh. Well, pick a point, another point, and another point. We call this A, B, might as well just call this D. Some different colors, make it fun. They didn't say what kind of triangle, they just said draw a triangle. Okay. Step 1, done. Find the midpoint of the longest side. Well, let's see which one's the longest. That's a little under 2. That's 1.9. What is this one? This one's a little over 2. So here we'll go. You know what? I'm gonna get centimeters. I like centimeters better. So AD is the longest side. Oh, cool. It's just under 6. We're gonna say 5.9. So 5.9, just under 6. A little less than 3. There we go. Okay, there's the midpoint. Rotate 180. Okay, I can do that. I'm running low on patty paper. Hopefully I can get some by tomorrow. Oops, forgot to do the point for D. Missing the Niners game right now. Why? Well, first of all, it hasn't started. And second of all, this is more important. Okay. So, 180 using the midpoint of the longest side. All right, that's pretty easy. Okay, there you go. And I have this right on that U for your. Okay, so that's what we're looking at. That's what they told us to do, so we did it. All right, so that's steps 2 and 3. Label the corresponding parts. So I know this one can go into this one. This side can go into this side. You got this angle right here. Can go into this one. And then this angle right here, we'll do 2 marks. So go into this one. There's an angle, 1, 2, 3. And there's its corresponding angle, 1, 2, 3. And last but not least, we got this side. Okay. Make a conjecture and justify it. What type of quadrilateral have you formed? This is known as a parallelogram. What's a parallelogram? Well, parallelograms got opposite sides parallel. So that one. And this one also. These are opposite sides parallel. So opposite sides parallel. Opposite sides congruent. And opposite angles congruent. Now, if you rotate a line 180 degrees, it's going to take it to a parallel line. Same goes here. Rotate a line 180 degrees, it's going to go to a parallel line. Opposite angles, that would be like this whole big one. Well, this one's 1 and 2. This one's 1 and 2. So those are congruent. And then we got a 3 and a 3. Cool. All right, the first one's done. We're just gonna go one by one on these pages. Okay. Page 179 in your workbooks. You're gonna find 2.3, are these parts congruent? So, triangle ABD. A, B, ABD. This is known as triangle ABD. Is a rotation of triangle CDB. CDB. Oh. There's my timer to go get all my tests that I printed out. Probably need another 15 minutes. Okay, so we rotate CDB around point E 180 degrees. It turns into ABD. Now they ask you, is angle ADB, this one, I'm coloring in red here. Is ADB congruent to CDB? This one. No, it's not. It's congruent to this one. What's this angle called? It's not CDB, it's CBD. So, you're going to say, nope. Angle ADB is congruent to CBD. And why is that? Well, you got parallel lines and a transversal. Those are alternate interior angles, which are congruent. So no, it's not congruent to this one. Okay, on to page 182. Let's see what we got here. Triangle HEF. Right here, this one in red. There's HEF. Is the image of FGH. So the red one's an image of the blue one after a 180 degree rotation of the blue one. So I always recommend you rewrite it. HEF congruent to FGH. We're talking about triangle HEF congruent to FGH. Okay. Select all that must be true. This is one of those order matters problems. Okay. If HEF is congruent to FGH, then we just gotta run the order. So triangle FGH, so that's gonna be congruent to HEF. Is congruent to triangle FEH? No, HEF. That's out. Triangle EFH, second, third, first. I know that's gonna be congruent to GHF. They said GFH. That's different than GHF, so that's out. Let's look at this angle here. Angle KHE. You always start with the first letter, KHE. They're talking about this angle right here. Well, I know that's going to be congruent to this one. KHE will be congruent to KFG. Angle KHE congruent to angle KF. Yep, there we go. This one's good. Circle it, check it, whatever you got to do. Angle GHK. Let's mark that one here. Could even color it in blue if you wanted. So I know that the alternate interior angles are congruent. So if they say GHK, GHK, you gotta start with what its corresponding angle is. So G's corresponding angle is E. So GHK is gonna be EFK. But they said KHE. So are they? These two are not congruent. So that's out. Segment EH congruent to FG? No. This is a trick question. E and H, right? It's gonna be GF, not FG. They said FG. You gotta go GF. That's out. Alright, let's look at segment GH. I know GH is gonna be congruent to EF. And that's what they said. So answer C and F on this one. C and F are true. All the rest are false. This one was close, but it had the wrong order. All right. Hey, we're done with one page. Get that puppy out of here. Okay. Next up. Number 7. Triangle HEF. Right here. HEF is the image of HGF. After we reflect across FH. So you reflect this blue one right here. You reflect it over this line, it becomes the red one, essentially. So select all statements that must be true. Well, let's look at the statements. This one's on page 180, 198, 199. Kobe. Should have said Smush Parker. Anyways. All right, triangle FGH. FGH. I know it's congruent to FEH, so it better be FEH. Yes, that is true. A is true. So you got to select all true. All right, here we go. There's a true one. Okay. EFH. Well, you got to get the order right. EFH, so second, third, first. You know it's going to be GFH. So yeah, EFH, GFH. All right. Those two are true. Let's look at angle HFE. That's this one right here. I know that's going to be congruent to HFG. But they said FHG, so that's out. Let's look at EFG, this big one. Oh, this isn't congruent to anything, but let's see what they say. To EHG, that's a no. Let's look at EH. I know EH is going to be congruent to GH. So segment EH congruent to FG, not even close. And last but not least, segment GH, what is it congruent to? EH. Segment GH congruent to EH. Yeah, there we go. Boom. All right. You wanted A, B, and F on that one. Okay, next problem. Sequence of rigid motions takes A, B, C to D, E, F. Do not say reflect over this line that you draw, this imaginary line. Just don't do that. Use tracing paper. Be a little more precise. So we got to go from A, B, C to D, E, F. So you go A, B, C, connect the dots. Okay, so we got ABC. There it is. All right, gotta go from ABC to DEF. And so I know A and D are gonna line up, so I always like to do that first. So translate A to D, rotate center D until C lines with F, and then you're here. So let me just do that again. So A to D, rotate clockwise till C lines with F, center D, and reflect over DF. So you got to write those things down. So here we go. Translate. Rotate. Reflect. Now, are we done? Nah, you gotta get the directed line segment. That is point to point, so you could just say A to D, or AD, excuse me. So if we just translate AD, that was our first move. Now rotate, gonna get your center. So center was D. I would have accepted A prime too. You got to get your direction. Direction is clockwise. Clockwise. And what are your degrees? Well, you could say angle C prime, A prime, F. Let's watch that. C prime, A prime, F. That would have worked. Easiest one is until C prime aligns with F. That's what I recommend. So clockwise until C prime aligns with F. That's your move to get here. And then last but not least, you got to talk about the line that we reflected over, which was DF. Over line DF, because that's the mirror. The mirror was DF. What's the image of BC? Well, let's see. Put a 1 there. So BC, if we do that. It's gonna be over here. But you gotta get the order right. So look where B lands. B lands on E, C lands on F. So the image of BC will be EF. Pretty easy stuff. Explain how you know these segments are congruent. BC is congruent to EF because rigid transformations. Preserve congruence, or preserve shape and size. Thus, corresponding parts are congruent. That'll work for me. That was on page 171. Hopefully you understood that. If not, just rewind the tape. Super easy. All right, 2 pages done. All right, let's move on to this one. These are not problems, but please review this. Okay. 2 pairs of corresponding sides. So there's 1 pair. There's 2 pairs. Ooh, should probably go get my stuff. Nah, I'm gonna keep rolling. And the angles between the 2 sides, let's just make them green. I haven't used green yet. If you got the 2 sides, 2 pairs of sides, plus the angle between them, that is known as side angle side. See, 2 sides, angle between them. Side angle side. These triangles are congruent. That's the side angle side theorem. All right, let's move on to this one. We got an orange angle marked with 1 little marking. Let's go back to blue. We got a blue angle. So 2 angles plus the side in between is known as, well, you get the 2 angles plus the side in between. Angle side angle theorem. These triangles are congruent. And then last but not least, you got pair of sides. Second pair of sides, third pair of sides. This is known as the side 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 theorem. And these are congruent. So these are the ones I taught you. Side angle side, angle side angle, side side side. Remember, angles got to be between the sides, sides got to be between the angles, and then all 3 pairs of sides. All right. Now, this one's been coming up a lot lately. The angle side angle, this one. You can be used that to show that opposite sides are congruent. Now I'll show you how. We have a definition of a parallelogram. It's defined to be a quadrilateral, 4 sides, with 2 opposite, or 2 pairs of opposite sides are parallel. We call those parallelograms. All right. And then this line right here, AC, let's define what AC is. AC is a transversal. So transversal. That's a line that intersects 2 parallel lines. So a line that intersects 2 parallel lines. What it creates is alternate interior angles, which you should remember are congruent. So alternate interior angles are congruent. So let's just color code those. There's one, and the matching congruent angle. So you got a congruent angle, another congruent angle. Cool. And then let's go blue. Look at this. Crazy pencil sharpener. All right, so then you got the blue one. That one's congruent to that one. All right, so you got red and blue, and then you got this side that they share. So what you can say, let's start with the red ones. You could say angle CAB is congruent. So CAB, the red one, is congruent to ACD. You can also say BAC. Oh, excuse me. Let's say ACB. The blue one right here is congruent to CAD. So there's your two angles. And AC congruent to CA. That's your side in between. It's shared side. Therefore, you now have two congruent triangles. And how do you know that? Well, you've got what's called angle, side, angle. So we're going to say triangle, CAB, this one, CAB, this one right here, is going to be congruent to ACD. ACD. And why? Because of angle, side, angle. Cool. So now you can prove that opposite sides are congruent. So last but not least, you just say AB congruent to CD and AD congruent to CB, because corresponding parts of congruent triangles are congruent. Hey, you can work in here, I don't mind. All right, let's go on to 7.3, finding the missing angle measures. Oh, these are so easy. You just need to know about vertical angles. Those are congruent. And linear pairs, those add to 180 degrees. So, we got 42. What's a vertical angle? Yeah, I'll give you an example here. Just draw two lines, super easy. 1 and 2 are vertical angles. 3 and 4 are vertical angles. So 1 congruent to 2, 3 congruent to 4. Two lines, they intersect. I love this little trick. Vertical. See that V right there? So vertical angles are congruent. Vertical angles. That's a good way to look at it. So vertical angles are congruent. All right, so what does that mean? That means C is 42. Now, linear pairs, you got a straight line. See this line going through that line? That means this plus this. So you could say A plus D equals 180. So A is 42 plus D is 180. Just got to subtract 42 to both sides. So you're going to find that D equals 180 minus 42. These just cancel out. So D ends up equaling 138. So then if this is 138, then B is 138 because vertical angles are congruent. Okay, the next thing they tell you is like lines L and M are what's known as parallel lines. That was given to you. So this line right here is a transversal. So transversal cutting across parallel lines. means we got some more angle relationships. So A is 42, right? E is 42. Why is E 42 and A 42? Well, A and E are known as corresponding angles. So that's 42. Let's just go back to our linear pairs theorem. So that's 138. Now it's just easy peasy. 138 again, and 42. You could also talk about alternate interior angles or alternate exterior angles being congruent. There's a number of ways you can solve these, but you just got to know vertical angles, linear pairs, and that's pretty much all you need for that. That was on page 216. All right, Tyler, good old Tyler. He has written an incorrect proof to show that quadrilateral ABCD is a parallelogram. So he knows that AB and DC are congruent. They really should have said CD, but whatever. He also knows that angles, ABC, and ADC are congruent. All right. So he knows these two are congruent. Same measure. Alrighty. He also knows, oh, here's where we left off. Find the mistake in his proof. Okay. Segment AC is congruent to itself, right? So triangle ABC, this one, congruent to triangle ADC by side angle side. Nah, he's jumping the gun. This is where he made a mistake. This isn't side angle side. This is side side angle. Side side angle. So he jumped the gun a little bit. What I would have suggested is that he mark this congruent to this, because you know it's a parallelogram with the transversal, so alternate interior are congruent, and then you could do angle side angle. So find the mistake in his proof. It's right here. Triangle ABC is not congruent to ADC by side angle side. It's congruent by angle side angle. So that's where he went wrong. He forgot to talk about these two as alternate interior angles. Gosh, I'm tired. That's what I get for leaving at 2:30 in the morning from Tahoe. Anyways, okay, that one's done. 2 more pages and I'm done and get to watch the Niners. Yeehaw. All right, here we go. Math talk 20.1, angle relationships. Let's just do these super quick. Parallel lines, transversal, 140, 140, 40, 40, 140, 40, 140, 61, 61. This is 119, I think. You just got to do 180 minus 61. Just get a calculator for that. Yeah, 119. So these are 119, 119, making this 61, 119, 119, and 61. And 25 vertical angles. Linear pairs makes this, let's see, 55. It's 55 plus 125 is 180. making this 55. And then, of course, this is 55 corresponding angles, 55 vertical angles, 125 linear pairs, 125 linear pairs. Ooh, this one's tricky. 98, well, this one's 98 vertical angles. This is gonna be, can't forget my tests. Not 102, but maybe 92. Let's see, no, 82. That's 82. Now you know this one's 82. That's 98. That's 98 vertical, and that's 82. 90 plus 80 is 170. 8 plus 2 is 10 is 180. All right. There's a number of ways you could go about those. You could have gone alternate exterior congruent. You could have gone alternate interior congruent. Or you could have gone corresponding congruent. Linear pairs, 180. There's a number of ways you can go about those. All right, here we go. Here we go. Oh, I like this one. Actually, this one I love right here. Let's talk about this. Quadrilateral ABCD is a parallelogram. By definition, means AB is parallel to CD. All right, sketch a parallelogram and draw an auxiliary line. Okay, one way you can do a parallelogram, like pretty easy, just use a ruler or a protractor. So here we go. A, there's A, B, C, D. So A, B, C, D is a parallelogram. By definition, that means AB parallel to CD and BC parallel to AD. Okie doke. Draw an auxiliary line to show how ABCD can be decomposed into two triangles. So, I'm just gonna draw this BD auxiliary line right here. Okay, so there's our auxiliary line. Let's go green for one of them. I don't know why I like high school math so much. Just a bunch of little puzzles. They're not that hard, which is kind of cool. Let's go, green and orange. What an awful color combo. Who does green and orange? Anyways, here's your two triangles they're talking about. So we did our auxiliary line. All right. There's our auxiliary line, BD. Prove the two triangles you created are congruent. Okay, easy. You got alternate interior angles right here. Do just a little 1 marker. And then you got that one and that one. Let's do 2 marks just to show that this one and this one are the same, this one and this one are the same. So then you got this side right here that they share. So that's basically what you gotta say. You gotta say angle CBD congruent. So CBD, that's this one, congruent to ADB. And you gotta say ABD. It's So angle ABD congruent to CDB, this and this. You're just going to say alternate interior angles are congruent. And then lastly, you're going to say BD congruent to DB. That's a shared side. It's known as a shared side. All right, so you got angle, angle, and the side in between them. So now you can say triangle ABD congruent to triangle CDB. And what's the reason for that? That is angle side. Angle, triangle, congruence theorem. Therefore, the opposite sides, like BC, is going to be congruent to DA. So, one pair of opposite sides, so BC congruent to DA. Reason being, corresponding parts of congruent triangles are congruent. Easy. Just gotta chip away at it. Ooh, I love this problem. Triangles ACD and BCD are isosceles. So ACD, the big one, and you'll see isosceles means two sides. So let's just define that. So isosceles triangles, two sides congruent. And the other thing about two isosceles triangles, if these two sides are the same, the base angles end up being the same. So two base angles congruent. Okay. Angle BAC, this one right here, has a measure of 33 degrees. Angle BDC has a measure of 35 degrees. Find the measure of angle ABD. So the goal is to find this angle measure right here. And basically, you just chip away at these. So I know that this triangle right here, BCD, is isosceles, which means you got the two sides congruent and the two base angles congruent. So then you say this one's 35. Okay. Now, this one right here is going to be, so first of all, we're going to say 35 plus 35 plus CBD, so angle CBD. Since they all add up to 180, we can now solve for CBD. So 35 plus 35 plus whatever this is are going to equal 180. That's the triangle sum theorem, which you should know by now. That just says they all add to 180. So then this one right here is just going to be 70 plus angle CBD equals 180. Angle CBD equals 180 minus 70, because you got to subtract 70 to both sides. So angle CBD equals 110 degrees. So you know this one's 110. Okay, let's see what else we can do here. I'm trying to prove that these two triangles are congruent. And I'll tell you why. If I can prove that, I'll color it in a little bit. If I can prove that this angle is the same as this angle in red, then I can prove these two triangles are congruent, because then I'll have side, angle, side. I'll have side, angle, side. So let's think about that. We already know that this big angle right here is called angle ACD. So we're going to say angle ACD equals 35 degrees plus angle ACB. Now, this angle right here is known as angle ADC. So angle ADC equals 35 degrees plus this one, ADB. We also know that because this big triangle ADC, the whole thing is isosceles, that the two base angles are congruent. So we know this angle and this angle are congruent. So you can say angle ACD equals angle ADC, right? This angle equals this angle. Which means if this equals this, which we just said right here, then this equals this. So let's do that over here. We're going to say this first part, 35 plus angle ACB equals 35 plus angle ADB, right? This equals this, because this equals this. So let's just get these. If you subtract 35 to both sides, you can do, as long as you do it to this side, you can do it to this side. But 35 minus 35 is 0. 35 minus 35 is 0. You are left with angle ACB equals angle ADB. So therefore, the red angles, which we colored in, are indeed congruent. So now 1 and 2, triangle 1 and triangle 2 are congruent. So now you can say triangle 1 is congruent to triangle 2. Why? Side, angle, side, side, angle, side. So you just say side, angle, side. That makes this 33. And that means that you got two orange angles that are the same. Wow, this is a tough one. So you got this angle is going to be the same as this angle, because corresponding parts are congruent, so angle ABC congruent to angle ABD. Reason for that, corresponding parts. Of congruent triangles are congruent. What is the total measure of this whole group of 3 angles? Well, that's 110. All 3 are going to add up to, what's the measure of a circle? 360. So you'll say 110 plus this equals 110 plus angle ABC plus angle ABD equals 360. Subtract 110, subtract 110. Angle ABC plus angle ABD equals 250. These are the same. We just said that. What plus what equals 250 if they're the same? 125. Woo, that's a fun one. So, finally, angle ABD equals 125 degrees. Done and done. Easy peasy. Oh my. Is that one going to be on the test? Heck no. That is not going to be on the test. That's a tough problem. But if you can nail that problem, yowzer, you're ahead of the game. It's just like chess, remember? You can chip away at these. Okay, one more page and then I'm donezo. I get to go watch the game, have some fun. All right. Here's a triangle, ABC. Angle measures ABC. Each side has been extended to a line. What is the value of A plus B plus C? A plus B plus C equals 180 degrees. Explain your reasoning. That's the triangle sum theorem. All 3 angles in any triangle will add up to 180 degrees. That's easy. All right, write a sequence of rigid motions to take ABC to DEF. Well, you can always do this. A, B, C, mark your labels. So, A, B, C. Well, I know A, B, and D, E are going to be the same. So why don't we just translate A to D, rotate until B and E line up and C and F line up. So you got to write that sequence. So 1, translate. 2, rotate. I think that's it. Yeah, translate, rotate. But let's talk about translate. You can't just say translate. You got to say the translation, which was AD. Then you rotate. Center D. Center D. Which direction did we go? We went counterclockwise. Direction. Counter counterclockwise. And what's the degrees? Well, you could say angle B prime, A prime, E. That would work. Because that's the angle right here. Right there. Or you could just say till B lines with E, C lines with F. But just to be technical, I'm just going to say B prime, A prime, E. So degrees. You can either name the angle or you can measure it. I'm just going to say B prime, A prime, E. And that's it. That was page 203. All right, more zigzags. Here are some statements about two zigzags. So you got A, B, C. Choose some different colors just to mix it up. Get some variety in your life. It's gonna be a long video. Gotta remember not to forget my tests. Okay. Put them in order to prove figure ABC is congruent to DEF. First one's gonna be a translation. This is the last step. Yeah, AB to DE. Let's do this. There's a rigid motion that takes AB to DE. Yep. Translate, rotate. Honestly, I'm not going to do this right now. Let's talk about what this is. ABC. Translate A to D. Rotate counterclockwise. The angle is B prime, A prime, E prime. It's the same one as this. They're just trying to like get you to put these in order. Ugh. Forget it. It's not that hard on the test. All right. That was an hour-long video. Hope it helps. Go Niners. Wonder what the score is. Let's see what time it is. 6:03. Better hurry up and watch. All right. Have a good day. Work hard. Help other people. That's what I'm doing here. All right, bye.